Okay, good morning. Welcome to
SuperMath181.
SuperMath181. We're a little bit pressed for time, so we're doing a challenge problem for our video today. Just going to do one problem. So it says we have a cone. We've drawn it ahead of time. We have a right circular cone with vertex V. Label that V. And radius 6 and height 6. Okay, so we got a cone who's 6 tall and 6 long. The sphere has a center at that vertex V and is tangent to the base of the cone. What is the radius of the sphere?
Well, the radius, since the sphere is tangent to the base, the radius is 6.
How come?
Because it goes from the center to a point on the outside of the sphere.
Okay, so the distance from... Oh, sorry, what am I saying? The radius of the sphere is the same as the height of the cone.
Yes.
Alright. Great. Part B. Let X be a point where the sphere meets the curved surface of the cone.
So maybe this is X.
Okay. Find the distance from X to the axis of the cone. The distance from X to the axis of the cone. That's a rare sentence that has the word X and axis in it, and doesn't mean X-axis.
Well, I don't think we know much about random points on the outsides of cones. But what do we know about X? Well, I know it's on the cone and on the sphere. This is the outside of the cone. And oops, I forgot to draw the back of the cone in.
Okay.
That's a point on the cone and on the sphere at the same time.
Alright. What does that mean, that it's on the cone and the sphere at the same time? Do you learn anything from that?
I don't think so. Just know that it's in two shapes at once.
Alright.
Maybe we could try to puzzle that out later. But I also notice that I have an isosceles triangle here. 6, 6, 6 root 2. An isosceles right triangle.
Okay.
And since these are both perpendicular, this is parallel to this, so you have another isosceles right triangle. Looks something like that. Does that help us, though? Well, it would if we knew any of the side lengths, because then we could use that to help us find this.
Okay. That's actually a great observation. So you're down...
Just to finding either this side length or this side length.
Okay.
Well... Is this point X actually 6 away from the center of the sphere? Because it's on the outside of the sphere.
Alright.
And this point from the center of the outside, that's the radius. So, I think that might work.
So go through that argument again. How do you know that? What makes you think that side length is 6? And which one is it in your picture?
It's this length.
In your triangle picture?
This length.
In this triangle picture here. Sorry.
It's this it's this hypotenuse from here to here.
Okay. So what makes you think that's 6?
Well, I think it's 6 because this is the center of the sphere. And I think these points are outside the sphere.
Okay.
But since this is both on the sphere and on the cone, this is on the outside of the sphere and on the outside of the cone.
Okay.
And a point and a line from the center of the sphere to a point on the outside of it is the radius of the sphere.
Interesting. Okay.
So that's 6. This is 6 over root 2. Just 6 root 2 over 2, or 3 root 2.
Root 2. It's actually very good work. You have to figure out, like, I got to know another, in order to solve this problem, I got to know another distance. Like, what other distance do I know? And for a point that's kind of a random point, like you said, on the surface of the cone, you don't really know anything. In fact, a random point on the surface of the cone isn't going to have any special properties about its distance.
Yeah.
But this isn't a random point.
It's a point on the cone and on the sphere.
It's on the cone and on the sphere, and that lets us know that it's 6, and that gives us the right triangle. All right, hey, great work.